Hey everyone, again, my name is Fan. I'm the technical marketing engineer for the CSR1000V. Hope you find my video useful. Today, I'm going to talk about how to use AWS Private Link in the CSR1000V HA deployment. Okay, let's jump into the topic. So here is typically customer deploy a CSR HA pair in VPC. So let's put the VPC detail for a second. Assume you have a VPC running, and typically you need to talk to an on-premise network. So that's probably will be IPsec over internet. So you will have an internet gateway in this case. And you probably will have a peering as well because you want to leverage the cross-region peering. And you have another VPC that sits in different region or within the same region, and then you can peer them together. You can use CSR to build overlay over the peering, like IPsec encryption. You probably will also have a direct connect if you are a large enterprise customer. You want this fast, stable connections goes between your on-premise data center to the VPC. So those three are the typically connection or the transport. I call that as different transport. If you look at the architecture of the VPC or inside VPC, you will find out mostly I found this customer, they like to divide into multiple subnets from a security perspective or from an easy management perspective. So if you have two CSRs in this case, you probably will end up with 4 subnets at least because you want to spread the subnet in different AZs. So you want to provide HA. So for example, you have CSR1 that's sitting AZ1 will have 2 subnets. So you will have a public subnet. You will have a private subnet where you have your application VMs running. And side by side, you will have the same equivalent topology in another AZ. So you will have a CSR2, which also has 2 subnets, public 2 and private 2, where you have your application running. So this is the most typical HA deployment I've seen customers using today. It leverages the AZ, different AZs. It leverages a pair of CSR in case one CSR fail. The tunnel or the overlay will not be teared down because you have another backup CSR. And it will also leverage your application, which can be running in different AZs. So this is the most common use case. And for those customers, they are familiar with the CSR HA, they will know CSR basically are monitoring each other's status based on the BFD session. And when the BFD failed or the labor is done, the CSR is going to update the private side route table and shift the route to the surviving CSR. So in this case, if you want to better leverage the AZ or you want to put the data within the same AZ, so typically if you have a VM in a private 1 subnet, the default route will be set up to the CSR1 interface. And for the subnet in AZ2, the default route will be set up to the CSR2 interface. So this will allow you to keep the traffic localized because the traffic that goes across AZs will be charged. So you want to leverage this capability. But if CSR1 failed in this case, the CSR2 will update the route for that private 1 subnet that's in a different AZ. So you will end up with a cross AZ communication or traffic, but you don't lose the connectivity. And I think most people are using this deploy model. And in order for CSR to update the route table, actually it has to make API calls to AWS EC2 API service. So that's a DNS-based service offered by Amazon, and typically it's a public DNS. So that's why on the left down side, you will see the AWS REST EC2 API that's accessible from the internet. So in order for CSR to access that API, the CSR need to have internet accessibility, at least from a egress point perspective. So people might have a concern on that because not every people are using internet today. They have air gap network. They just using peering. They just using direct connect, which means they don't even put IGW or Internet Gateway in the VPC, or even they put in the VPC, they don't want people just to assign public IP to their EC2 instance and that EC2 to access the internet. So that's typically the concern from the security team, I would say. That's going to be this slide. So people want to break the internet access, or they want to stop that internet access for all the VMs within the VPC, which means from this public route table perspective, you will not have a default route to the internet gateway. So in order to achieve that, you probably notice if I remove this internet gateway, how can I CSR reach out to the AWS REST API? Because that's a REST API can only be accessible from the internet. If I stop that connection, if I plug that connection out, how can my CSR still be doing the HA or to be doing the route shifting in case of the failure? So that's what I want to introduce, the AWS Private Link. So this is a feature AWS introduced in their last reinvent by end of 2017. And actually I was an attendee there, so I joined the AWS reinvent. When they open this service to the customer, I think, okay, we might be able to do something with this feature. So now I figure out if you don't want to enable the internet accessibility for your VMs, especially from ingress point of view, you can use the private link for the egress point of view. So what private link provides today is gives you it's like you can have a private line all the way to the services. It could be AWS services itself, like the EC2 API I mentioned in the previous slide, or it could be your own organization services. For example, if I have a database running a different VPC, I can use my peering. Say I have application VM or web server running, and that VM is in a different VPC of that database. You can use peering, you can use IPsec VPN to build that connection, or you can just say I create a endpoint service, and that service can be that service called database service, and that service can be attached to your VPC specifically. So now you don't open the whole access for the whole VPC, you open the specific endpoint, and that endpoint will be linked to your database. So this is a more granular control of your resource within cloud. And typically, if you want to create your own endpoint, it has to be a load balancer based, because AWS want people to provide the elasticity and also the HA solution. They don't want you to just spin up a VM and then provide the service, because if that VM fail, then your service is down. So they want you to use their load balancer. But in this case, I'm not going into that direction. I will just use their endpoints to the AWS services. And you can see on the slide, it can also open the service to your partner services, like a SaaS support, right? For example, in our networking world, if you want to collect the net flow information, before you have to reach out to that net flow collector specifically. Now I can just say, okay, I'm a third-party vendor. I provide net flow collector information, and you don't have to reach out to my public IP address because you have a concern. Now I open my endpoint to you. You just reach out to the endpoint based on private DNS. So that's the power of private link. It's very powerful. So let's take a look how we can leverage on the private link in the HA deployment and remove the internet gateway. So as you can see in this case, the internet gateway is gone. So there's no internet accessibility for this VPC, but you can still use peering. You can still use direct connect. In order for the CSR to reach out to the AWS REST API, I create an endpoint service in my account or in my VPC. And there are multiple endpoints. So it could be a gateway endpoint. It could be an interface endpoint. So in this case, I'm using an interface endpoint. And when I say interface endpoint, actually, it will be represented as a ENI or Elastic Network interface within your VPC. So in this case, you can see in the route table side, the default route to the IGW has been removed. You don't need that in this case. But the route table has a link to the endpoint. And just to make sure, this link doesn't take entry in your VPC route table. So you will not see it in the VPC route table. But when you want to create the endpoint, actually, you need to link your endpoint to the subnet. After you have linked the endpoint to the subnet, so AWS backend will know, okay, I need to put a hidden route in those route table that has been associated with those subnets. So from an end user perspective, what you need to do, enable the interface endpoint, associate the subnet you want those endpoint to take effect, and that's it. But make sure you enable the private DNS, because from a CSR perspective, we are calling the API, we are still using the public DNS API. So if you think from a CSR perspective, it's making the same exactly API as it made before when it has the internet access. So CSR is still using the public DNS name to make the REST API. But in this case, the DNS will be resolved within the VPC, and it will be redirected to that endpoint and then access the AWS REST API. So this is pretty clean way to enable the private link and also remove the internet gateway. But CSR can still do the HA. So let's take a look at my demo setup. As you can see, the internet gateway is back on the topology again. That's not for the CSR to make the HA, that's for myself to log into the CSR, because once I remove the internet gateway, I will not be able to log into the CSR. But in this case, I create a Bayesian subnet where you have a Bayesian VM running in a different subnet. So you can see that's 30.0.4.0. Because that VM will have elastic IP, so I can reach out to that VM via internet. That's the route table has a default route point to the internet gateway. And because all the VM within the same VPC will be routed by the AWS infrastructure, so my jump VM will be able to access the CSR1 and the CSR2, so I can see if CSR1 and CSR2 can make up the REST API in case of the failure. So let's jump into the demo. So I'm going to show you how the HA works currently, and I'm going to show you how to transform the current HA by removing internet gateway, by enable private link, and make sure that still works. So here are the steps, pretty simple. Remove your internet gateway from the CSR subnet route table, so the CSR will not be internet accessible. Enable the DNS, so you need to go to your VPC settings and enable DNS host name, enable DNS support, so that's part of the requirement for the private link. And also create an interface endpoint, and you need to enable that private DNS for the VPC, and that's it. So there's no additional configuration you need to do on the CSR. And below there's a link about the private interface configuration guide. You can use that guide. It's very, very comprehensive guide. So let's jump into the demo. So here's my AWS environment. So I have two CSRs. I have based on VM, and actually this VM is not used. So let me just add something. Not used. Okay, you don't have to worry about this VM. Let's take a look at the route table or the VPC. So this is my VPC, which has a HA, a pair of CSR, and I have 5 subnets as I described, and based on the same name. I like to keep that in sync with my presentation. And the route tables. So the route table, let's dig a little bit into the route table. So for the private side, I don't want to spend too much time because you can see it's only associated with one subnet. The public route table, which I said without IGW, actually that is the route table associated with the CSR public subnets. So I have CSR1 and CSR2 here. When I see without IGW, actually that means I will remove the IGW later, but currently it has IGW, so I can log into the CSR. And this is my basically VM route table, which has definitely has internet gateway, so I can log into that base machine. So let's take a look at the private subnet. So I don't want to confuse you guys with two private subnet route table because they are used for different VM. I want to separate different AZ traffic to different CSRs. But in this demo, let's focus on this private subnet one. I have set it up to this ENI, which basically is CSR1 ENI. Let's double check. Goes to the CSR side. And let's say we have two interfaces. The Ethernet one will be the private side facing, so it's end with 90. And here's 90. Okay, life is good. Let's log into the CSR. This is public IP I got from the CSR, so you can see I can log into the CSR. I have my high availability configuration, and I'm setting the BFD peer. So this is exactly the HA configuration you probably have today. And my side is 90, and my peer side, what is the ENI? We can quickly check on this side. Okay, it's FD. Okay, so let's verify if the HA works today. And to verify HA, you don't have to do like reload the CSR. Basically, HA is triggered by the BFD session done. So we can just say, let's shut down the tunnel on my CSR1. That's the BFD tunnel. Let's enable the terminal monitor so you will be able to see the log. Shut down the tunnel. So the second CSR notified the BFD immediately, and then it says, okay, I got to update my route table, and I successfully updated. So let's go to the route table here, and let's do a refresh. Okay, you can see it updated the route table to a different ENI for this interface. Right. And what is the ENI? Okay, so here's ENI 32. Sorry, I probably confused the route table and the ENI before. So the correct ENI should be end with 32, and here's 32. Okay, so life is good. Every people is happy. But security team comes, okay, I don't want you to log into the CSR directly. I don't want the CSR to have internet access at all. So let's put the state back. And also let's update let's change the route table back to use CSR1. So let's reverse back to what it should be in the beginning. Okay, so back to our steps, what we should do. First, remove internet gateway from the CSR subnet route table. Okay, let's do that. But before that, let me log out first. So my session will not hand there. All right, so let's remove the internet gateway. Sorry, not from here, but from this without internet gateway. Let's remove this route. Then immediately you probably will not be able to access the CSR again, right? So you cannot log into the CSR. There's no internet access for the CSR. So, but let's log into the base machine first before we go into any steps. All right, so here's my jump VM, and I guess I probably logged in that before. Okay, yes, so this is the IP, and this is the IP. Okay. And in order for your jump VM to log into the CSR, you either can create a local VM username password on the CSR, or you can leverage the same message key, but you need to upload the key first. I already uploaded the key on my jump VM. So, and I think, yes. So in order for the jump VM to log into my CSR, you definitely want to use a private IP. So CSR1, private IP, I'm using this 186. So this is the IP. All right, so I'm in the CSR1 now, as you can see. CSR2, the private IP, I think I'm using this 1.132. Let's see if I have that. Okay. Yeah, I have that. Okay, so I'm in the CSR2 again. All right, so there's no internet access. I think if you do a show, say PW Cisco, yeah, you won't get DNS at all. Even you will get a DNS, but you will not be able to send the packet to the real internet because there's no internet accessibility. All right, so we verified this. Let's go back to my DNS setup for the VPC. So let's switch to the VPC page. So you need to go to the VPC page, select the VPC itself, and typically you can see here, by default, when you create a VPC, your DNS resolution will be yes, and the DNS hostname is no. So what DNS resolution does is AWS will resolve your DNS request. That's the reason that you can see my CSR will be able to resolve my cisco.com to this specific IP address because there's no internet route to this IP address. So that's why I don't get an ICMP reply. So that's the DNS resolution does. The DNS hostname does is it will create a private and a public DNS name for your EC2 instance. So if you don't have that enabled, so it will not create a public DNS name for your own VM, and you can find more detailed information on aws.com. But according to the private link to use the private DNS, so you have to set those two options to yes. The first part is already set to yes, we need to change the second part. Edit DNS hostname, change to yes. Okay, so we are done for the second step. Third step, pretty easy, create interface endpoint. So finally, we will take a look at endpoints. Forget about endpoint service at this time because this is service you want to create and other people will be able to use. So you will be the provider and other people will be the consumer. But in this case, you want to become the consumer. So that's why you go to your endpoints. Let's create an endpoint. So we'll just choose AWS services. And you can see there are multiple types. So i3 and DynamoDB, they are the gateway type. But in this case, we want to just to reach to the EC2 API. So that's interface type. And now let's select the VPC. So it's my spoke. It's my spoke B. Okay. Then we need to select the subnet. So that's basically where you need to be careful. So let's go back to the topology once more. Okay. So if you think from a CSR perspective, when you want to make the REST API, so it's gonna look up its own. So it's gonna do a DNS first, and when it has a DNS IP address, as long as you have, unless you have a specific route to say, okay, this DNS or this API, you need to use my gigabit 2. Otherwise, it will always use the default route interface, which will be the gigabit 1. So that's why this endpoint has to be enabled in the public subnet for the CSR, which will be the first interface. So make sure you select the public subnet. Okay, and you can see you can only select one subnet for each AZ. So you need to be careful on that. This is part you need to make sure it's enabled. So you have a private DNS name. And to use private DNS name, that's where it says you need to make sure your DNS hostname and your DNS support are set to true for your VPC. And we already done that in the second step. So in this case, we don't have to do anything. Security group, because this is interface type endpoint. So if you need it's like an ENI in your VPC. And for any ENI, you have to select the security group to allow certain type of traffic. So in this case, I'm just gonna use my. I think security people are not like this. I basically have a allow all, but I don't want to create any issue in the in the security rules. So I use allow all here, but it's a better to change to limit the IP address of your VMs. Okay, so before we hit the create button, let's just verify if it works without endpoint. So I'm gonna go to the VPC page and verify what is the current next hop for the route table. I want to do a filter first. So it's a spoke B. And I go to the route tables. This is my private route table. And you can see it's using 90, which is a CSR1. So let's go to the CSR1. And let's try to shut down tunnel 0. This is a previous log. Let's just clear it. Let's try to interface tunnel 0. Shut up. Okay, let's check on the second the CSR. So as you can see, you don't see that successful messages again, and it will keep doing the API call, and after the timeout timer, it will say, okay, my route update API failed. So it means I cannot reach out to the EC2 API. So let's check the route table again to see if it still stays with 90. Yes. So nothing changed. So it means it doesn't work if you remove the IGW and you don't add endpoint. So let's try to shut down the tunnel and make sure it's back. So as you can see, those are the messages. Let's just clear the message and create endpoint and see if the endpoint will help you in terms of HA. So based on my experience, the endpoint creation takes some time. Could be a minute, could be a couple minutes, but it shouldn't be over, like say, 10 minutes or yeah, it should be around a couple minutes. So I will pause the video and I will resume the video once it's being available. All right, it just becomes available literally like a second ago. So the endpoint is available. Let's check the route table and make sure it's still using 90. And you will see the public route table side, there's no entry for the private link, and that's expected because AWS will do this in the backend, so you don't have to worry about that. Okay, so this is still 90. Good. Let's try to shut down the tunnel again on my CSR1. All right. You see that? You see this successful? That means the HA take effect and it works. Let's just do a update my route. Okay, just refresh. So it's 32 now. So you can see after remove the IGW and enable the endpoints, the HA starts to work again. So this really show you a way for those customer who has a security compliance and they want to remove the internet access for the VPC, but still being able to leverage the HA solution because they have a VPC peering, they have direct connect, and they still need CSR to be set up as a HA pair. Hope this video is helpful to you. If you have any questions, just leave your comments at below of the video and I will respond. Okay, thanks again. Have a good day.